Today, I want to talk briefly about the chain rule. So, the best way to understand the chain rule is just to look at it and use it in some examples. So, if we have something like this, where we need to find the derivative of 2x squared plus 3x, and then this whole thing is going to be to the power of 5, right? Now, what could you do? Well, you could go and just multiply this out 5 times, but that's going to take a lot of time and not be very fun, right, and be pretty strenuous. So, what do we want to do instead? Well, the chain rule says if we have a function like this, where we have an outer function, in this case our outer function is this thing to the power of 5, and an inner function, this thing here, then we can take the derivatives of each one of those and multiply them by each other. So the way to think about this is, let's call this inside function u to the x, okay? So just this one bit is u to the x, so that equals 2x squared plus 3x, all right? And then we also have f of u, right? And then u is this whole thing, so this equals u, and then when it's f of u, it's u to the fifth, right? So now what do we want to do? Well, we want to take the derivatives of each one of these and multiply them by each other. So the derivative of this is 5u to the fourth, right? We can just utilize the power rule. And the derivative of this is 4x, no, sorry, yeah, that's 4x plus 3, all right? So then we can say that the derivative of this equals 4x plus 3 times 5u to the fourth. Well, 5u to the fourth, right? That is 5 times u. U to the x, as we said before, is 2x squared plus 3x, right, to the fourth times 4x plus 3. So here, using the chain rule, we have our derivative of this right here. So let's box that. All right. So now, let's actually take a look using trigonometry. Let's do a very, very simple problem. So let's say we have 3 sine of 2x plus 1, right? And we want to find the derivative of this. Well, in our case, the 3, right, is going to stay the entire time. We're not going to touch that 3, okay? Our outside function is sine, right? And our inside function is 2x plus 1. So if we take so 3 is going to stay, all right? So then we also have the derivative of sine is cosine, all right? And we can't have cosine of nothing, so it's going to be 2x plus 1. And then we take this, right, what's inside here, we take the derivative of that and multiply it by this. Well, the derivative of 2x plus 1, all right, is just 2. So multiply times 2, right? So this whole thing equals 6 cosine 2x plus 1. Okay? So let's look at another example where we can use the chain rule. So now, if we have just some ordinary number, let's use 4 in this case, over, well, this, actually, let's just stick with 1 for now. 1 will make this the easiest, right? If we have 1 over 3x plus 2x squared plus 1, right? And then this whole thing is to the fourth power, okay? So we have this, and we want to find the derivative of this whole thing. So what can we do? Well, this whole thing, we can take this up to the top, and we can make this whole thing to the negative fourth power. You might be tempted to use the quotient rule with this, but we can use the chain rule and it'll be much, much easier. So this equals 3, actually we'll put it in 2x squared plus 3x plus 1, and then this whole thing to the negative fourth. Okay. So then, let's remember, what do we want to do? Well, we can say that that's a D, u of x equals 2x squared plus 3x plus 1, right? And f of u equals well, in this case, we have to the negative fourth, okay? So the derivative of this is what? 4x plus 3 again, and the derivative of this is negative 4u to the negative 5. So then we can say, well, and then this whole thing equals negative 4u equals this up here, 2x squared plus 3x plus 1 to the negative fifth. Then we just want to come back up, and we can say that this whole thing equals 4x plus 3 times, actually let's put the negative 4 up front, negative 4 times 2x squared plus 3x plus 1 to the negative fifth. And if you want to, you can take this thing down and put it as a denominator below. Now, I hope this helps you understand the chain rule just a little bit better. Let's quickly, before we conclude, take a look at some examples of when we won't want to use the chain rule. Well, if we just have 3x plus 1, do we want to use the chain rule? No. If we have the derivative, dx, if we have of cosine of just x, right, do we want to use the chain rule here? You could use the chain rule here, but this is not complicated what's in here, so we can just say that this would equal negative sine of x, right? So then also if you have like 4x squared, right, the derivative of this, do you want to use the chain rule? No, you don't want to use the chain rule. You can just use the power rule, right? So there are certain circumstances where you'll want to use the chain rule, where you're going to want to use the quotient rule, and you're going to want to use the power rule and the product rule. So you just need to keep those in mind, right? And just work through some problems. And as you work through problems, you'll start to get when you need to use which rule. I'll make a video on the quotient rule and on the product rule pretty soon. Thank you for watching.